So now we're going to talk about two independent mean tests. And we call these t-tests. A lot of times you'll hear them as two mean t-test. And it's different than when you're talking about the paired t-test. So let's look at the hypotheses. So for independent sample t-test, we're talking about each sample of I've got two I'm comparing, are independent of each other. They don't depend on anything for anything, any event, any outcome. So again, think of it as like if I'm comparing two classes' exam grades. Exam one is not dependent on, class one does not depend on class two. So think about those kind of things when you think about independent samples. So again, everything is pretty much what we looked at before. The only big difference is, look, for the null of the left-tailed, the mean of sample one is greater than or equal to the mean of sample two. And then the alternative is the mean of sample one is less than the mean of sample two. When you're doing these kind of problems, make sure, again, that you put the sample that is being described first. It will save you heartache in the end, I promise. So always do that. Just make sure you're leading with the one it's talking about. Right-tailed, again, same thing as left-tailed, except the only difference is in the alternative, it's greater than, and in the null, it's less than or equal to. And two-tailed is basically the same. So when you did the one-tailed test, you saw those before, the one mean t-test, you saw those before. The real big change for this is instead of having a number on the right of the mathematical sign, you have sample two. All right, so let's start looking at this. Okay, two independent samples. Okay, so for two distinct populations, which we're going to be looking at because we're getting two different independent samples, if your sample sizes are small, the distributions are extremely important and they should be normal. If your sample sizes are large, the distributions aren't that important, so they don't need to be normal. So there's really important rules for that. For this class, we're going to assume they're all normal. If you took a different statistics class of non-parametric tests, we look at data that's not normal and how to handle that. So two independent samples. So when you're comparing two population means, it's really very common. So when you look at two samples, you're looking at two different means and two different standard deviations. So a very different mean can occur by chance if there's a greater variation about individual sample types. So like if I wanted to look at say education levels for people who live in the Northeast versus the Southwest, they could be different. So those kind of things that I'm looking at, I'm comparing two things and I'm looking to see how different they are. So in order to account for the variation, we take the difference of the sample mean. So we're saying that the sample mean of one minus the sample mean of two and divided by the sample error in order to standardize the difference. This is the result of the t-score test statistic. You know this is the t-value. So, and you'll get this for this again. It's not a big deal. You saw it with one mean t-test. Well, because we don't know those population standard deviations, we have to estimate them using the two sample standard deviations from our independent samples. Again, we're not doing two sample z-tests. That's when you might know your population standard deviation. Here we're not. Okay, so here is the standard error, which is the estimated standard deviation or the difference between the two sample means. We're not going to do this by hand, so don't worry about it. It will be given to you, but we're really not going to stress about it now. I really kind of want you to understand how these tests are run. So again, I'm just showing you the formulas. Do you have to memorize them? Nope. Do I care if you memorize them? I wouldn't waste your time. There's more important things that we're looking at. Let Minitab do the work for you. So the t-score is going to be calculated this way, but again, we don't have to worry about it because Minitab does it for us. I just wanted you to see the formulas to see that basically what we're doing is we're looking at the samples, we're comparing them, and that's how we get the information. The degrees of freedom requires a somewhat complicated calculation, but we're not going to have to worry about it because Minitab does it for us. All right.